I want to introduce your two speakers for today. We have Adam, who's the National Sales Director for Micatu. He brings years of experience helping utilities find the right solutions to enhance their grid, and his experience with various smart grid solutions helps greatly round out his understanding of outcome-based applications for utilities and partners alike. And we have Sean, who is the Director of Customer Programs and Planning, and with many years of hands-on experience in the utility space and beyond, Sean brings his unique understanding of ways to enhance the grid. Bridging the gap between solutions and addressing opportunities for utility partners is something he's incredibly familiar with, and his client base will tell you that his vision is a shared one in solving issues plaguing utilities. So we're going to have both of those guys for you today, and we will begin with Adam. Adam, I'll welcome you in. Thanks for being here today. Adam, I believe you're on mute. There you go.
Yeah, sorry about that. Yeah, thanks a lot, Dana. I appreciate it. We're looking forward to presenting at least our take on the infrastructure itself, what it's going through, and the role, at least from a partnership perspective, that we at Micatu are able to provide, and what we see in working with our customers. Share the screen here. So, like I said, from our perspective, being a Micatu, working with a lot of the customers in the electric utility industry, I'll roll through this one. We have what we believe to be a good insight into what's going on. We're going to share that with you. I have a handful of slides I'm going to go through. When I'm done, Sean has some interesting items he's going to talk about in regards to use cases, kind of how our technology is applied, what we are seeing with customers in regards to some of the issues, and what are some of the solutions that we're seeing, and how we are able to help as a provider for the utilities that we work with. Following that, hopefully we'll have some time and we'll be able to jump into some questions. So looking at the kind of the space as a whole, talking about what is the new normal. So kind of going back and looking at it from around 1890, not since the first electric lines were laid, the public power supply has literally faced a huge fundamental decision on how to reliably and effectively and safely push the power to the consumers. And so if you're thinking about it from that perspective, most of the grid today was built around the 1950s or 60s. With that, it had about a 50-year life expectancy. So we're running into borrowed time. We're running up against it right now, and we're seeing it with things breaking and problems happening on the grid. With some of the challenge that our customers are facing, new power sources in multiple forms that are coming online, renewable power, solar, wind, biomass, geothermal. Looking at what they must do in terms of modernizing their grid. In order to facilitate grid modernization projects, utilities are charged with numerous and complex tasks that's facing a triple threat, like I mentioned, renewable integration, power quality issues, and reliability concerns. Utilities are being asked to do so with an aging infrastructure and outdated equipment, which makes it very difficult. Modernizing the grid means that more of the customers have to look at things holistically. So it's not just updating wires and adding in bidirectional capacity. It means they have to be able to detect and measure and understand everything that's going on at different points and multiple points to try to get a better idea for how to use the technology, all while they have a limited infrastructure, limited budgets, and reduced manpower. And so some of the goals that we have up there that utilities have to look to meet, in addition to ones that are federally or state mandated, it's decarbonization. They have severe weather impacts, DER integration, as I mentioned. The grid has to become rapidly responsive, dynamic, flexible, self-healing, more resilient ultimately. And so it's tough to do that with an aging infrastructure and limited time and budgets. Kind of where we come in and what we have seen in working with a lot of our customers, the bottom line is yesterday's technology of the past cannot take us to the future. And so, as I mentioned before, being able to kind of accurately monitor, measure what's going on in the grid in real time and in more places is vital. They're going to need access to data points, as you can see here on this grid, digitally. So analog devices are not going to cut it. sensing systems to help drive operational technology platforms and giving greater visibility and operational efficiency. It's going to improve reliability matrix. It's going to reduce outage links, the frequency of those outages. Reduced manpower makes it very difficult. So you do need to rely on grid modernization and next-gen technology. A lot of the traditional technologies that utilities have out there, like CTs, PTs, old-fashioned grid sensors, they all create points of which are not only inaccurate, but they're dangerous and they're ignition points and they're not safe to work with. As far as applications, Sean is going to talk later on about some of the popular applications or usual applications that we run into. But in terms of increasing reliability, increasing access and visibility and management into critical loads, and then managing the influx of distributed energy resources around the points of disturbances that PQ issues are causing. As you can see here, we have some of the main points up at the top: the need for real-time situational awareness, granularity into the voltage and harmonic disturbances, like I've touched on, more access to data and digital data points, not analog, but digital, for the sensing systems to drive the back-end technology that's going to make all this work. As far as bridging the gap from where things are at versus where they need to go, some of the common questions that we run into with our customers, and Sean can reiterate this, but it's how can they monitor the grid better? How can they get access to the data that they need to give them the ability to address the challenges that we just discussed and to innovate to make it a better future? So to take it from where they're at now to where they want to go. I know I keep touching on it, but the idea of yesterday's technologies and solutions to gather that detailed information that they need is just not cutting it. So legacy PTs and CTs or bird-on-the-wire line sensors have gotten us this far, but they're coming up short when it comes to modularity, affordability, accuracy, and safety. And so these points here with DERs coming on board, across the board, it's creating issues. Harmonics, and you need to be able to sense it and mitigate it. The data that is needed to compute on the back end, the operational technology that all of our customers are investing in, distribution management systems, outage management systems, and SCADA systems, distributed energy resource management systems, they need accuracy, they need real-time telemetry into what's going on to base it off of versus just modeling. So when we talk about optical sensing, some folks that we work with are very familiar with it. It is a newer way to do things. Optical sensors can be deployed indirect for field management that can provide information needed that traditionally other sensors can't. So kind of what is it in a whole? It's a very accurate, easy to deploy modular system that gives operational teams the information they need right away in real time. Why is it better? That's a question that always comes up. So instead of measuring the grid the old-fashioned way with a lot of the legacy technologies like I mentioned, like a Rogowski coil or legacy CTs or PTs, optical sensing is based on the Pockels effect, which is voltage sensing, and then the Faraday effect, which is current sensing. And so by measuring the intensity of the modulation with the beam of polarized light, you can address and outperform any sensor on the market. As far as some of the other major concerns that our customers have is safety. Obviously, safety is at the top of the list with everyone right now. So optical sensors are one of the safest ways to gather down information. And in terms of next-gen technology that's going to help the utilities, and it is helping them reach their goals, optical sensors are the best way to do it. They don't pass electrons, rather they measure the electronic field using the light that I mentioned through those two methods, passing through an optical crystal, which removes all the safety risks associated with legacy instrument technology like transformers that can become an open circuit, and it can harm people, it can blow up, it can catch fire, and they're not safe to work with. As far as flexibility and ease of use, the deployments for optical sensors are very easy. They require fewer forced outages, They can be put up in the matter of hours using a hot gloved or hot stick. So they're very safe. They don't pass any electrons, so there's no fire risk. There's no safety risk in getting hurt while you're installing them. And it's fewer forced outages, as I mentioned. As far as bridging that gap, I know I talked a little bit about from where we are now to where we're going. A quick background point. So the company that Sean and I work for, Micatu, was one of the first to commercialize this next-gen optical technology and sensing measurement platform, which is being used by customers all over the US and all over the world right now. Micatu has bridged the gap and done a really good job and to continually look ahead to see what are the challenges that are coming down the pipe by using the actual requirements that help steer and develop the new sensor technology. So at the top of that list is accuracy. That is the most important, and it is very, very important to us at Micatu. Optical sensors lead the industry as a whole in accuracy, whereas our sensors are tested to be up to plus or minus 5.5% in accuracy on both voltage and current. I know I mentioned safety keeps coming up as far as a requirement, both in older legacy technology and newer technology. As I mentioned, with traditional grid measurement devices, they're not sophisticated enough to pull down the accuracy, and they're not very safe. So moving forward, a lot of our customers, they're looking for better ways to do it versus traditional measurement devices. As far as optical sensing technology and its capabilities, they go a step above and beyond what traditional technologies have been able to do. So legacy technologies like PTs and CTs that have provided voltage and current information, some sort of phase angle with some level of harmonic information. Optical sensors can do that and then some. As far as harmonics, they're able to gather down a very granular information out to the 250th harmonic level on the voltage and the 11th on current. Detailed information from a power factor perspective, non-shifted phase angle, the complete swing of temperatures, as well as AC, DC basic information, and then total harmonic distortion. So when you're looking at trying to modernize your technology out there to help drive the operational side on the back end while being safe and easy to deploy, it's a no-brainer in going with optical sensors. It's a great fit for a lot of different solutions, which I'll cover here in a minute, or a lot of different applications. So talking about how the problems are being solved, or how we're addressing the challenges to solve the problems, Micatu is really turning the information into a digital approach because data has become the new currency. We have a grid modernization effort in place where we're offering an affordable, easy solution to deploy in almost every scenario or application. In the medium voltage market, that's 4 kV up to 69 kV and 72 kV. We have designed the sensors, and as far as technology goes, it's some of the easiest to deploy for a lot of the retrofitting of existing systems, whether that's in a substation, overhead situation, or inside gear, or even underground. The GridView M410 processor is what you see here at the bottom of the screen. That is what converts all the sensor data that is being collected and driven, and you can transfer that data back through numerous communication protocols. A DMP 3 is very accurate, and it's usually the preferred method that goes back through a standard format into the centralized operational system that I was talking about that a lot of our customers have. So providing that data in a seamless method back into that OT software or technology like an ADMS or a DERMS is really driving a lot of value and helping a lot of the customers that we work with make better choices with less manpower and saving a lot of time and money. And so it's a big return on investment. In terms of looking at a lot of the problems that we're going to talk about, or a lot of the applications, folks ask why Micatu. One of the main reasons is trying to sum it up in that there's huge growth of renewables, and there's a lot of unknowns out there. So it's really hard to argue the fact that in this time, when grid modernization is such a key paramount in trying to deliver the best power and process for your customers. Using breakthrough technology like the optical sensors here can really give you better data. It's a safer option, more visibility into what's going on out there in real time, because you don't know what you don't know, and then being able to make actionable choices to try to resolve those issues and be proactive versus reactive in the situations. So what I want to do now is we're going to flip it over to Sean Monroe, who's the Director of Customer Planning. He and I are going to talk with you guys about some of the projects and success stories that we've been able to work on, what technology has been involved, and how that situation has kind of played out for the customer, and then we can open it up for questions and answers.
Great, thanks, Adam. Yeah, as Adam said, my name is Sean Monroe, Director of Customer Programs and Planning for Micatu. I've been here a little over 6 years, so I've done quite a few of the development projects that we've had with particular customers out there. You know, a lot of this has been us trying to develop and implement, you know, kind of retrofitting into what their needs are. But you know, as an overview of a few of the installations that we've done, you know, where we were able to standardize, and these have all, you know, become SKUs that are now offered by the company, you know, we were able to standardize into remaining equipment that's already out there or in the infrastructure. One example of that is the underground infrastructure that's in a lot of the urban areas, bigger cities. You know, as I'm sure most of the people on the call would know. You know, that a lot of the grid infrastructure in urban areas is all underground, and you know, when you're driving through the cities, you don't see any power lines at all. You know, with the infrastructure being the way that it is, it's very difficult when there are issues that happen and equipment needs to be replaced. One of the you know, beneficial solutions that we came up with was being able to take a voltage sensor, as you can see here, building it so that it can be fit into any standardized load break elbow. In this particular application, where this particular customer, where this picture is here, you can see the three-phase elbows, you know, that are into the system. The bushing the copper piece that's inside of the bushing fits in, you know, connects into the elbow, and we're able to pull, as Adam kind of alluded to this earlier at a high level, you know, we're able to pull the voltage measurement all optically. If you can see the cable coming out of the sensor there, that is all just a fiber optic cable. You know, we measure using the E field that's generated on the inside of the sensor, and obviously, you know, each one of these sensors we're going to talk about has a little bit different form factor. But inside of the gray cylindrical area there is an E field that's generated with a bulk optics sensor. We're able to measure that or carry that data back to the M410 and measure the voltage that's on the lines. You know, again, what's most important here is if there is any equipment that needs to be replaced, you know, us being able to come in and you know, at a very low cost to retrofit into original equipment there. That was kind of the problem that we were really trying to solve here. You know, most cases we're kind of faced with a lot of different options. You know, and in this particular instance, another issue that we were asked to try to solve is, you know, trying to, with it being underground, trying to mitigate any possibility of floods, you know, flooding of the underground cabinets, and you know, especially due to the storms that we've seen There's been a lot of money that's been given in grants to try to increase the hardiness of these of where this equipment is placed. And you can see we pointed out here the NEMA 6P enclosure. We were asked in this instance to create an enclosure that can be used underground, and this was actually tested at 30 feet underwater for 7 days. So we're often tested on trying to come up with solutions to seemingly very difficult problems. And although a lot of these have kind of been spurred by customers' issues, specific customer issues, they really are a general issue across the board of what we're seeing in a lot of these applications in the underground areas. Adam, do you have anything to add to the underground situation here?
No, you touched on it really well there.
Perfect.
It was good. Do you want me to switch slides here?
Yeah, let's go on to the next one. So another problem that we see in the grid is capacitor bank control, and a lot of you're going to see a lot more customers using this method in the field as we're faced with a situation where as the current demand goes up and there's a lot more inductive loads out on the line, you need to control that volt-var control or have that volt-var control to be able to put it back to a resistive power or a resistive load. So a lot of customers are putting out cat bank controllers, and being able to have very reliable, accurate sensing to be able to control that or to be able to send that information back to the controller is really important. And we've actually deployed our sensors. This particular example here is a line post sensor, and we also, which I'll show in the next couple slides here, we have a line hanging sensor. Essentially, they're both doing the same thing. They're a combination voltage and current sensor that is just used in different applications. This particular one would replace a line post or a sensor that would hang on a post, and the conductor would sit on the top of it. But essentially we're giving, and thanks Adam, this is a perfect a better look at it of how this would sit on the post. As you can see, we would hang or install the sensors on here, install the conductor wire on top of the sensors. The cables would come down the pole, and then we would have our controller in a NEMA enclosure box on the bottom of the pole, and the cat bank control would be somewhere in that array next to the M410 NEMA enclosure, and the M410 would feed the data back to the controller in order for that to be able to get the measurement of what they needed to use. So. Yeah, I mean, again, this is something that we're seeing a lot. We've deployed this, we've deployed thousands of sensors across the country using this particular, application. And, there's several different, companies out there that are offering this cat bank control that we can integrate with and have integrated with in the past. So, and moving on to just one more option. Yep, thank you. So substation monitoring. Obviously, this is anybody who's in the industry, and I'm assuming most of the people on the call are in this industry. But if you're not, then maybe you're learning something a little bit more about it. But I guess it would probably be household knowledge what a substation is. But there's a lot of value that the industry has put into these substations and building these infrastructures. And anytime that you have to replace a PT or a CT or any equipment in the substation for that matter, you would have to cause an outage, redirect, power on the grid, and that can be a very costly effort. Our solution in this instance, as pictured with our line hanging sensor, the RG235, as Adam alluded to earlier, this sensor in particular can be hung with a hot stick or a glove by a single person in a bucket truck. There's no need for bringing in a mobile substation. There's no need for causing any outages or having large crews or bringing in lots of equipment in order to do all of that work. In this instance, we can basically just replace a PT with our sensor and by quickly just hanging it on the line and offering the reliable and accurate sensing that a lot of the other equipment that would be causing a lot of that additional cost, and we're able to just quickly come in and when I say quickly, we have basically in this picture in particular, we hung these 3 sensors in here. I was there for that day actually. We did this in about 6 hours from top to bottom. That's including a safety meeting in the beginning. So it's a fairly quick effort in order to install these sensors. Going back to quite a few of the things that Adam touched on before, safety and lower cost. Obviously, these are all very big points in what we're trying to do here with our sensors and our sensor design. There's three different options. Obviously, there's so many different form fit applications that we've done. Per however the grid is set up in any particular area, I'm sure that we'll be faced with many more in the future. When we get to the point of the Q&A, if anyone has any questions on that, I'm happy to continue that conversation or take that offline. But pretty much, part of my job, a major part of my job has been just working with customers on new integrations new possibility to work into their configurations that they have out there. So with that, I pass it back over to you, Adam. And
yeah. So that's a great job, Sean. And I think what you've shown and what we hopefully have been able to convey is the message. The grid is changing. There's a lot of issues that utilities are faced with. So from an integrator standpoint, with either technology or a software solution, it's our job to help kind of usher through some of the changes that need to happen to the grid to help them further provide the best possible service to their customers in a safe way that is a low cost, easy to deploy and manage solution that will last a long time, not just a quick fix, because it's not going away with some of the changes that we're seeing coming on with distributed energy resources, the bidirectional flow issues, safety issues. We see wildfires going on left and right out west. So anything that a solution provider like Micatu and some of our partners can do to provide is a win. I know Sean mentioned there's a lot of different applications that we run into in terms of here's the problem and what solution are we able to provide. What I want to do now, so in terms of this presentation, I wanted to kind of throw it back to the audience here. And Dana, maybe you could facilitate it. But in terms of questions that folks on the call are possibly having or that have come up throughout the presentation, or issues that they're running into or being challenged to address at their business, Sean and I would love the opportunity to talk with everyone about that, or to get an idea for some of the problems that they're running into, whether we can talk about it now or maybe take it offline at a later date and time.
Yeah, I would love to bring the audience in now. So you can either just raise your hand and you can join the conversation with us, or you can put your question or comment in the chat window, and I'll make sure that Adam and Sean get that as well. So open for discussion. You can either raise your hand or place it in chat. So I'll start it off. So what is the basic time frame for installation of optical sensors? What's the project timeline like?
So from conception to feasibility to deployment, if you're talking about a lot of our customers and the typical approach that we see, so the timeline for that, the evaluation period, we usually roll into a pilot program and looking at a couple of different applications at their site, providing the sensors. We integrate the data back into their operational system for instant analysis and return, and then go from there. As far as the installation process for that, there's not a lot involved. It's not a big overtaking or undertaking, should I say. It usually just takes a couple hours. You really don't need to de-energize any lines unless you have to and you have standards around that. But it's pretty benign, and it's an easy process, and we'd love to talk with folks about it if they're interested.
Anything to add, Sean?
Good question.
No, Adam did a good job in covering that. It's very difficult for us to say that we have kind of an out-of-box solution for everybody, because everybody has different needs and different applications and uses or builds their infrastructure a different way. To kind of touch on the point that Adam made, we've really tried to standardize on having kind of a pilot package for customers that we have created, where we kind of it's all inclusive and ready to go for them to kind of move into their configuration as basically just the combination sensor package into the M410. But really, what from that point on, obviously, we can show them what we can do with that, but really the meat and potatoes of what my job is we having to figure out the solution of how our sensor integrates with what their issues are, right? How do we solve the problems that they're having? So we have a lot of in-depth conversation about that, which is really good, and usually will spur something else that they may not have even thought of before. One of the kind of interesting things that always comes up is we have so many features. I mean, we could spend this whole time talking about all of the features that obviously Adam and I are very proud of the products that we stand behind, and we could talk about that all day long. But being able to present that to a customer or present a feature that we have that serves a need that they didn't necessarily even know that they needed. Really getting into creating the or coming up with a solution to their problems by using our sensors, which gets spawned by starting with a pilot, and that. To kind of circle back to your question about time frame, that can cause a little bit of an added time frame into the whole mix of everything. But as Adam said, generally it's a pretty quick process. For the most part, customers know what they're looking for when they come to us. But yeah, and then also to Adam's point, as far as the installations, it's each of our sensors is done a slightly different way. The line hanging, the line post, the underground. So obviously there's quite a few precautionary you have to have a safety meeting and things like that. But from us literally rolling up to the site and packing up to leave, we've done that all within 6 to 8 hours. So it's relatively a pretty quick installation.
Thanks. Dennis has a question in chat. He wanted to see some more pictures of the sensor, if you guys are able to show it, or maybe go back to the pics that you had in your presentation. He said they were a little hard to view. Do you have anything else that you can show us, or maybe better description? Dennis, maybe you could come on and ask what you're looking for. Maybe that would help. You're welcome to join us, Dennis, if you'd like.
No, I'm okay for now. I guess we can continue with the question answer session.
Okay.
Perfect. And Dennis, please feel free. Sorry, Adam, you're probably going to say the same thing. Please
Yeah.
feel free to reach out to us offline, and we'd be happy to send you any technical information, including some better pictures that are a little more visible to see. Be happy to do that. Thank you.
Great, thanks.
Yep.
All right, any other questions? Anybody's welcome to join in. Hands raised. We can just discuss some of these issues as well. And so you can raise your hand and join in or put your questions or comments in the chat. So you mentioned this briefly, but what about the safety of optical sensors compared to what utilities might have been using in the past? Is there a safety improvement there?
There is, yeah, and that's a good point. And I know I touched on it briefly. As far as the safety goes, so unlike traditional, let's say transformers, PTs and CTs that are non-optical sensing technology, they're conductive and they pass electrons, so they're not easy to work with. It makes them dangerous for both field engineers as well as ignition sources or ignition points on the grid. And so a lot of our customers, whether they're looking into trying to remove ignition points from their grid without sacrificing the lack of data or the need for accuracy, or the need for voltage and current information, looking at an optical sensor not only gives access to those items, data points, but also makes it a very safe option in return to working with it. So from a personnel standpoint, as well as it's not an ignition source on the grid. And so, it's not going to blow up. It's not going to catch fire when it gets hit with, different voltages or even a lightning bolt. It's not going to catch fire. It's not going to be an issue. So it's very safe from both an application standpoint and using it, as well as from a deployment standpoint in the field and being safe to its surroundings.
Can the both of you talk a little bit about some of the grid measurements and analytics and some of the things that your clients and utilities have been using the sensors for, and what kind of changes, almost like a little bit of a case study on what their issues have been and what you've seen, what their biggest needs are, I guess.
Sure, yeah, I can start off and then Sean can elaborate on it. As far as like a general use case, so folks want access to very accurate information in real time or near real time to be able to help drive the operational back end of that and to be able to get real time visibility into their system. As far as voltage and current measurements, very important. That's some of the most you also get with our technology, and you also get with the optics, is able to provide more. So in regards to, like, from power quality perspective, phase angle, detailed harmonic information, total harmonic distortion, you can have a better idea for what's going on out there that you can't normally see or pick up with traditional or legacy technology. That's something that all the customers that we work with and folks that we talk with want or need access to. So there's different ways to get it with our sensor technology, the GridView platform. They're able to get it, and it's a very affordable way to be able to access a lot of information and get a huge bang for your buck. And Sean, I don't know if you want to be able to expand on any of that.
No, that covers a lot of what we do, Adam. I appreciate that. I guess I'll Dana, if it's okay, I can pick up Justin's question here.
Yeah, that'd be great.
Okay, great. So, Justin, we've got many different ways of communicating to the device, the M410. You can go DMP3, we can go LEA, depending on it really comes down to exactly how you're going to be using our sensors. If you're using them for power quality or using them for using them to integrate with another piece of equipment. But we do have a serial connection, a DMP3 connection, a LEA connection, and yeah, that's about it. But
maybe as far as Sean, expand on communications in terms of the relay of information. So we don't have an internal communications built into the M410. We can utilize whatever communication path that the customer wants to use. So it's pretty open, which is nice. We don't have a lockdown. You have to use this 4G version.
Yeah, absolutely. Thank you, Justin. Did you have any other questions around?
No, I think you hit on it. I think Adam kind of answered my general question. Was more, the common path that you see this communication protocol going through. So we use DMP3, but we end up hitting our tacks that go back to head-in systems or whatever that come through backbone systems to get back to our office. But I wasn't sure if there was a particular device. So it sounds like that M410 is the collection means of that optical information, and then it disseminates from there. Is that kind of am I on the right path?
Got it. Yep. Absolutely.
Okay.
Thanks.
Yeah, I think that answers the question. Thank you.
Okay, perfect. Yeah, and again, please feel free to reach out to us if you have any other questions on that. Dennis, each one of the sensors has a different voltage range, and that's a great question. So the couple sensors that we showed, the one hanging right above me is 4 to 35 kV voltage range. We don't the voltage class is a range, and it's not set up as each individual sensor has its own voltage class. The line post is a 4 to 25 kV range, and that really just comes down to the size of the insulator bushing that's on there. We've got lots of different options for voltage class, and right now we're pretty much going up anywhere between 4 and 72 kV.
Medium voltage market. Yeah.
Yep. Does that answer your question, Dennis? Perfect.
He says yes. Yep.
Yep. Great. You want to take Jerry's question, Adam, or you want me?
Where are the questions at here?
I can read it for you. It says, how do the sensors perform under heavy ice loading? And it's Jerry Settle has the question.
Maybe expand on that a little more, Jerry. Not sure I understand the question.
Jerry, you could just turn your mic on and join us and ask the question if you'd like.
Yeah, we're just talking about not just the sensing, but the communication aspect of what is sensed as far as the current and voltage. So if the entire sensor is loaded with ice, is there an issue with communication?
So I haven't personally run into any customer impacts with heavy ice loading. It's a good question. From a high level perspective, the way the sensor is, and we can pull different photos back up, or we can jump on another meeting offline. The way it's sensing and gathering information and then transferring it down the optical line back down to the M410, which is in an enclosure. I don't foresee any issues, with that. But like I said, I haven't run into it, and I think it's a good question. I don't know, is it something that you've ran into in the past, issues with sensors gathering data, or?
No,
Seems like
not specifically.
Okay, that's a good question.
Can I,
John? I don't know if you have any input on that or expand.
No, I was just going to say. I mean, obviously, there's I've heard stories of some other sensors that are in the market that rain and ice and weather has been detrimental to the readings of it. From that aspect, we don't have anything. I mean, from your question about does it affect the communications portion of it, all of our data is gathered through optical cable. If there was a situation where there was a large amount of a large load of ice that was on the cable and it was sagging the cable down, there would not be an issue necessarily unless it was pushing past the bend radius of what the cable can handle. I mean, I don't ever want to say that there would never be an issue because I've seen some pretty bad ice storms. But I think for a general use case, I don't think that there would ever be an issue. with the ice gathering on the cable that would cause an issue with communication back.
So staying with that weather idea, being from California, what about heat on the other side of, we've talked about the ice loading, but what about the, extreme heat? Are there any issues with that?
Sean, do you want to
roll? Yeah, I feel bad, Adam. I feel like I'm answering most.
No, go for it.
So, jumping right in here, but so Dana, to answer your question, no, we haven't had too much issues with heat. I mean, obviously, sensing all of this over temperature is it comes with its ups and downs, but we have a fairly robust system in here, and we are over a temperature range of -30 to 70 C. So we feel we feel pretty confident about that's pretty much most of the world's temperature ranges. So we really haven't had too much issue with extreme cold or extreme heat. But obviously, it has taken a long time to get to that point to develop, the technology so that it can cover that range.
Looks like Justin had his hand up. Justin, you want to come on in and ask your question?
Yeah, I was just gonna, I guess, ask kind of to touch on Jerry's point, maybe not so much the ice being on, I guess, being in the electric utility industry, we're not, at least I'm not personally familiar with fiber optic cabling, right? I don't deal with joint, communications all that much from that aspect. So I guess, I don't know if maybe this answers Jerry's question or asks it in a different way, but as far as degradation in consistency or accuracy or speed of that communications, is there any issue with, extreme icing or cold or extreme heat on the other end?
So that's a great question. No. So it's really interesting. The market that we're in with fiber optic technology. Everyone assumes that fiber optic is just telecom, but we're using it in a very different industry, and a lot of our battle is kind of trying to explain to people that are in the utility industry that our cable is just as robust as copper. And that's always been a very difficult conversation, but it is. The cable that we use, the fiber cable that we use, has a Kevlar jacket. It has a PVC outer jacket. The manufacturer of the cable that we use claims that they've driven a Sherman tank over it. So it is a very robust cable, and we have not seen any issue as far as signal degradation over temperature or anything. Like I said, I think the only thing I can think of that you would ever, or the only case that I would think of that you would ever have an issue with maybe signal loss or signal degradation is if you did, have an instance where the cable was bent past the bend radius. And it would cause harm to the actual the actual fiber that's on the inside of the cable. But no, the light the light passes through the fiber optic no matter what temperature. It's a very robust system in that matter.
Well said. That's good. Yeah.
All right, we still have a few minutes left. If anybody else has a question or wants to, join in the conversation, share any issues that you're having, that's all welcome. Can you guys talk to us a little bit about wildfire mitigation? It's so important for the West to get the data they need without introducing sparking risks. And I assume that your technology is very helpful in that arena.
Yeah, sure. Yeah, and not to reiterate what I was just saying. It's as far as a safer way to get some of the most accurate, fastest data in real time out there. Optical sensors are the best way to do it. It's not an ignition source. It doesn't pass any electrons like traditional technology, and so in regards to wildfire mitigation, we have had tremendous success in working with customers in fire-prone areas, which is much of the U.S. West, in helping them look, plan, and deploy around removing ignition points on their system. Traditional technology that in the past has posed a risk, whether it's overhead or even underground, and then providing a sensor package that can fit that, meet the needs, and then some, all in a safer environment, safer way to do it. Sean, do you have anything to say from a project?
Pretty well describes it, Adam. Yeah, absolutely. Yeah.
Some of the big IOUs in the West are, like PG&E in particular has an undergrounding project coming up and moving more toward undergrounding. Your sensors are going to work in that application as for underground lines as well, right?
Oh, absolutely.
Absolutely.
Yeah.
Yeah, and as I said, trying to really push on that, to your point with PG&E, trying to make that infrastructure as robust as possible with the potential of flooding and so on and so forth. That's really what we've been working on, having an enclosure that can encompass our M410 and keep it safe under those conditions has been, it's taken a long time to develop it, but we've definitely come a long way with that. So yeah, we're absolutely prepared for those scenarios.
What about that history? How long, was this in development? Tell me a little bit about how you got. I know you had some slides at the beginning about that, but I assume that you've had a lot of people working on this for a long time.
Yeah, we absolutely have. The technology, started off as basically just having the RG235, which sits behind me, and a lot of different integrations with customers and kind of developments have kind of caused us to go different ways with the packaging. It's each one of our sensors is exactly the same. Bulk optic sensor on the inside of the insulator. It's just the way that we use it. To your question, I do have to kind of throw out there, a kudos to NYSERDA. We've done some partnerships with them where they've given us some grant money to try to increase the robustness of the grid, especially when it comes to the potential of storms and flooding and so on and so forth. We've had some really great customer partnerships in those grant contracts. They've been very interested in trying to solve these issues as well. So we haven't done it alone. We've had a lot of really great partnerships, a lot of really great teaming up and with both customers and vendor partners. We're all working towards a common goal here of trying to really increase the reliability and the accuracy of the grid, and try also, it really comes down to affordability as well. We all really want to try to find means of lowering the cost for trying to go out and replace equipment, lowering the time of outages. There's so many other things that roll into this, like I said, we haven't done this alone, and it's been though it's been, well, I've been with the company, like I said, a little over 6 years. So I would say probably about 8 years that Micatu has been working on this technology. So yeah, it's been a little in the scheme of things, it's a short amount of time, since the advent of electricity. But it seems like it's been a long time, I guess. But yeah, we've had some really interesting kind of development projects that turned into what we have as our SKU list.
We have about 3 minutes left, so unless we have any further questions from the audience, I think we can do final comments from the two of you.
don't see any other questions. Yeah, as far as the final comment, if folks do have any other questions or would be interested in learning more about our product line of sensors and discussing some of the projects that we've been involved with, or how it might fit for a project that they have coming up, or at least trying to conceptualize what it would look like, Sean and myself would be more than happy to schedule a time, discuss it in detail with you. I know there was a question about the sensor lineup and pictures. We have a lot of pictures. I apologize for not having more today that provided a better kind of view of what they look like, but be happy to schedule a time to go over it with you, and or anyone out there that has more questions on that or would like to see it. So Dana, I appreciate you and EUCI facilitating today's meeting, and I hope it was beneficial in looking at some of the challenges that our customers are facing, and as far as the industry is facing, and at least our unique approach, and to trying to help them with it.